All right, so we had this. We had something that kind of looked like this at the top of the page, right?
Yeah.
All right. All right. Sounds good. And then we had a dot that was like here, right? You're here.
I know.
Hang on, Dwyer's here too. He just went to go get something.
Thank you.
I was making sure it was a warmer seat. All right. And we had already done 1 through 6. Is that right? Or what did we do? I forget.
I think we'd already done 1 through 6. Yeah.
1 through 6. All right. So let's see if we can work this through. Problem number 7. We have the limit as x approaches -2 of f at x. And this whole goofy looking thing. So notice there is not a positive or negative that's listed. So this means we are going to approach -2 right here. We're going to approach -2 from both sides. Okay. Now here is kind of the problem. And I bet you could follow along with my really bad artistic drawing. Okay. This is coming from the left. Agree?
Yeah.
And this is coming from the right. Agree?
Yeah.
Friends, do my fingers get to the same spot?
No.
I can't go any further. So this one stops here. This one's going forever.
So that means it does not exist.
The limit doesn't exist. Okay? So you can write the DNE, which always, as a teacher, looks like students are writing 1. But DNE does not exist. No limit exists there. And then if I go to number 8, we want the function at -2. Okay? The function at -2. This has to be a point. Okay? So it's going to get to here. So we're not looking for a limit. We're just saying, hey, at -2 in the x direction, where is this happening? This is happening at 3 in the y direction. Okay? It doesn't matter that the limit didn't exist. The actual point, because there was a solid dot at that juncture at -2, that's why it exists. Okay? Then number 9.
Yeah.
Limit as x approaches 6 of f at x. Again, there is no positive or negative that are there. So we're coming from both sides. So at 6, this is where 6 exists. Okay? So I'm coming up to that purple. So as I come from the left, I'm on this one. As I come from the right, I'm on this one. Do my 2 fingers wind up in the same spot?
No.
That one does not exist either. Does that make sense how I'm saying that?
Mm-hmm.
So DNE again.
And so would you only write DNE or would you write the point that doesn't exist?
Nope, I just said it was DNE because it was a limit. And then let's see. Let's change to a fancy color. Ooh, I like pink. I'll go with pink. Number 10. Number 10, the limit has, I think it's supposed to be x goes to a negative infinity of f at x. Okay, so negative infinity is way this way. Where does it appear? We can't see any more of that graph, so I think that graph's going to continue going this way. Where does that graph seem to be pointing in the y direction?
Positive infinity?
Yeah, positive infinity, good. Okay, and then go with orange. Number 11, we want f at 6. So we're looking at this 6. What is the exact solid dot that I'm looking for? Which is there. What is that y value? 5. Then, I don't know, it's black yet, so we'll go black. All right, number 12. We want the function at 10.
0.
So 10 is right here. And that happens to be the point 10 comma 0, so it would be just 0. Okay. Any questions on that official cool page? Thank you. Thank you. Adios. So, you guys want to hear something pretty cool? So that young lady who just left is from Brazil. Doesn't speak any English. I record my lecture the day before in Algebra 1. So if you walked into my third period class, she has her computer open. She's watching my video with the subtitles in her language. And she's killing it in my class. Like 93%. My fifth period, I have 2 Spanish only, 3 Spanish only, and 1 who only speaks Arabic. So you walk into my fifth period, there's 4 computers open, 3 of them are translating to Spanish, 1 is translating to Arabic. I gotta tell you, the world has changed so much in the world of teaching. Like, kids that are, I used to teach at a school that, back in Nevada, that you might have 7 or 8 different languages that are solely only spoken. And there's me trying to teach math in English. Could you imagine sitting in a class? I mean, I realize sometimes math for some people is already a foreign language, but I mean, it's changing. It's cool. Happy the technology's there for it. All right, so I did the next page, problem number 1 only. Does that sound about right? All right, let's see how we do here. I think I can draw this XY axis a little bit. Try and get this picture. All right, and I'm going to go here. And go here. All right, so we go here to here, up to here, to here with an open dot. There's 5. I think I have enough with that. Okay. All right, let's see if we can go through this. So the limit as x approaches 0 from the negative side of h at x, in our equation's h at x. Okay? So this means I'm coming from the left. The negative is raised to a negative, or 0 raised to a negative. So I'm going to 0. I'm trying to get to here from the left. So where does this appear it's getting to?
5.
5. And then h at 3. H at 3, this has to be a dot. So this is the value we're looking for. So what value is that? They both happen to be 5, okay. And then I had the limit as x approaches 3 from the left. Okay, so 3 from the left. So I'm coming here. What does it appear I'm approaching? What y value? 2. Does this limit exist if I go this way?
No.
Okay, this one exists because it says, hey, I'm coming from the left, so that's going to give us that 2. But if it came from the other way, it's going to give us a different value, which means that the actual limit doesn't exist. So that's 2. And then we go limit as x approaches 0 from the positive of h at x. So I'm coming from the right. So I'm approaching this way. That's also going to be that 5, right? Or is it 5? Is it 5? Yeah, it's 5. So this one's 5. And then h at 0 has to be this point. So that's 5. And then limit as x approaches 3 from the positive side. So it's going to come to here. So that's going to get us to 5. That should have been h and x right there. And then let's see, green, another color, more colors, light purple. Then we have the limit as x approaches 0 of h at x. There's no subscript, so I'm coming from both sides. Do these come to the same point? Yeah, so 5. And more colors. That looks like vomit, but we'll take that color. H at -2 is right here. So that's going to be 0. And then I don't know what color I should use. Let's go to custom. Let me use that one. And so the limit as x approaches 3, this means coming from both sides. It better get to the same one. So as I come to 3, are my fingers, did they get to the same spot? Does not exist. Okay, so let's take a look at that'll work. Okay. Let's take a look at problem number 2. All right, so on these ones, when they give you the equation, being you're allowed to use Desmos in this class, which I highly encourage, what I would do is I would just graph it. So all I'm going to graph is y equals 34 plus x. And then I have to kind of zoom out to find it. And we are approaching -35. Hello, Mr. Dwyer.
Can I speak with the dumb blonde kid?
All right. So we want this, the limit as x approaches -35. I'm coming on the red line. I'll make that darker. All right, I'm coming on the red line here. Are my fingers getting to the same point if I came from the left and the right?
Yeah.
Yeah, so my limit is just -1 on that next question. So the limit as x approaches -35 of 34 plus x was -1. Okay, because I came from both directions it met. Problem number 3 that's there. Problem number 3. We have x squared minus 9 and we have x minus 3 over x minus 3. Okay. All right, and we want the limit as x goes to 3. So I'm just doing x equals 3. Okay. What do you see right there? It's a hole. Okay. So what value is that? I mean, basically, if I wanted to actually find that value, it appears to be 6. But why is it 6? So we're going to keep 6 on the back burner, but let's define why this works this way. The top becomes x minus 3x plus 3. And then it's over x minus 3. So it was undefined as is. But if I go and knock these out, I wind up with x plus 3, which means I'm going to take this value here, plug it directly in for 3, so I get 3 plus 3, which is 6. So the limit, this answer, the limit is x approaches 3 from both sides. Though it does create a hole, that what we're approaching from both sides is in the y direction 6. Dwyer, did you get in big trouble? Did your dad catch you playing with matches again?
No.
Throw rocks at cars? Did you blame me for that one?
Yeah.
Okay. No, as long as I'm always your guys out. You guys get pulled over by the cops. It's Stirrup's fault. Who's Stirrup? It's my math teacher. He says okay. All right. Let's take a look at number 4. Number 4 is the limit as x approaches 7. Then we have x squared minus 8x plus 7 over x squared minus 6x minus 7. Okay, I bet you this could factor, but there's a couple of other things we have to take into consideration. Let's graph this on Desmos. Y equals fraction. Then I have x squared. X squared minus 8x plus 7 over x squared minus 6x minus 7. All right, and then we want to say x equals 7 is our limit. Did I get that in there right? Okay. So come on, light up. So they're saying that the answer comes out to be 1. Okay, if I approach that from the left or to the right, I get to that 1. But let's see exactly why this took place. So basically the math that's taken place, sometimes we can directly substitute this value in for all of our x's. So I'm going to get 49 minus 56 plus 7 on top. I get 49 minus 42 minus 7 on bottom. So that's going to give me 49 minus 56 is negative 8 plus 7 over 0. So that gives me negative 1 over 0, where that's undefined. So let's see if we can find that undefined. There's our undefined. Well, no, it does exist because it's a limit. A limit can approach a hole, but we just have to make sure why it was undefined. So let's think about how this problem could be worked differently to where we could get that. So let's go back to algebra 1. I'd say x minus 7, x minus 1 is what the top would factor to, and then x minus 7 and x plus 1 should work. Those cancel each other out. That's where the whole, that's what made the whole. So then I'm going to take x minus 1 over x plus 1, and I'm going to directly plug 7 into each. So I'm going to get 7 minus 1 and 7 plus 7. So I'm going to get 6 over 14, which is 3/7. So I was off a little bit. So where would I get that 3/7 from? I'm just trying to think on my graph on Desmos. I'm going to zoom in on this, see if we can exploit this a little bit. There's the undefined part of that whole. Okay, so I'm just trying to think how we could utilize Desmos to be our most valuable property if we weren't good at factoring. I mean, we're getting pretty close to that region. And this would just be a matter of you saying, hey, how close can we get to this? So obviously the purple creates the hole. That's why the purple looks all goofy. So if you follow the black up, where do you think this kind of goes right in between the two? So we're at 0.75. What do we get here? .75, 3/7. Somebody on a calculator, what's 3 divided by 7? Close to half?
0.42.
0.43 roughly?
Yeah.
We're trying to see if we how close we can get to 0.43 can we get? God, we're so close. It has this whole region as undefined. Yowzers. I mean, look, as I go to left or right, look, it looks like it's beep, beep, beep. Dead. So I'm not quite sure how I can make Desmos utilize this anymore. Well, that's what a hole looks like on Desmos. Can you guys see the purple?
Not really.
X equals 7 is defined as this beautiful black line right there in the middle, but that purple is what a hole basically looks on Desmos. So sometimes on these, what you want to do is you would want to factor if you can. And then once you factor, you reduce where the hole would take place, and you keep the x minus 1, x plus set. That should be an x plus 1. Oh my gosh. You can't take stirrup anywhere. That's a 1. That becomes an 8. That becomes a 3/4. Okay, I feel better about myself because I'm pretty sure I got that 0.75 in there. 3/4. Okay. Jeez. Sorry, guys. You can't take me anywhere. All right. Friends, looks like we have a limit that goes with the revenue. But let's have you all work on and finish limits 4.1. All done. Back in front. And we will go over any questions you have next time we have class. Deal?